Hey, students, it's Mr. Pouts, and we are here for section 5.4. And section 5.4 is all about point-slope form. So it's another way to write linear equations. We've really focused in on slope-intercept form, and direct variation is very similar. It's just where the intercept is 0. But now I'm going to show you a different way, that you'll see equations written. It might be helpful in certain instances, and it's not quite as used as often as slope-intercept form. But the goal is I can write and graph linear equations using point-slope form. So we're going to write and graph them. I have it broken up into three parts: writing equations in point-slope form, graphing them, and then writing equations given 2 points, which is what we've done already with slope-intercept, but we're going to do it a different way with point-slope. And I'm going to break this up into two videos. So the first video is going to have sections 1 and 2 today. And what an awesome picture in the background, don't you think? I don't know. I just saw this as a picture of the day, and it looks awesome. I don't know how this works or how this happens, but it looks like it's a real thing, and like all those that huge swarm of fish up by that one scuba diver, pretty cool. But anyway, has nothing to do with what we're doing today. But here we go. So what is point slope form? So if we read right here, it says the definition: point slope form. So this is one key vocab word. The point slope form of an equation of a non-vertical line with a slope of m through a point x1, y1 looks like this. Y minus y1 equals m times x minus x1. So right here is probably your best way of showing it. So if you look, it's y minus y1. It's a really weird looking form, but y minus y1 equals m times x minus x1. So we still have, actually, if you think about it, slope-intercept form had the slope and the y-intercept. That's why it was called slope-intercept form. Point-slope form gives you, so the numbers in the point-slope form give you a point, so an ordered pair, and the slope. So we still have the slope, and that's right here, the m. And we're also given a point that's on that line, just a point. And that would be the point where the x value goes in for x1, the y value goes in for y1. So an example would be y minus 2 equals 1/2 x minus 3. So from this we can tell the slope, the m, is 1/2, and there's a point. Um, the x value was x1, so that's the coordinate goes over by the x. Here would be 3, and the y would be 2. Whoa. Y would be 2. That is on the line. So let's start writing some of these. All right, let's look at this first example. Writing an equation in point-slope form. So I won't show you too much yet, but let's see. A line passes through -3 and 6. So this might be an example you might want to write down. It's a very simple one, and it has a slope of -5. What is an equation of a line? So remember, point-slope form is y minus y1 equals m times x minus x1. The x1 and the y1 are the point that you'd plug in, and the m is the slope. So these are the three parts that have a number. So if we look here, there it is written again. That's point slope form. Now we're given a point. We're given -3, and remember that's the x, so that'll be the x1 that we plug in. That's right here. We're given a y, which is going to be our y1. That's going to be going in for the y1. And then we're given, oops, I hit it. Then we're given the slope, which is -5, and that's going to go on for m. So if you put it all together, it's going to look like this. Y minus 6 equals -5 times x minus -3. So we substituted the point in there and the slope. Now there's one more thing we have to do. Since there's minus and negative, this should just become a plus. So it's y minus 6 equals -5 times x plus 3. So anytime you see a plus in the equation, that means that you had a negative value, because it's supposed to be minus, you see right here. So if you subtract a negative, so it's a negative y value or a negative x value, that's when it becomes a plus. So Oh, just a follow-up question. What point is on the line represented in this equation? So the slope was right there. The slope is 2. But the point would be x1, y1. So just like we were talking, the x1, you might think this is a 2. But since it's plus, that means that it must have been an x, because it's supposed to be in subtraction. So it must have been an x minus negative 2. That's how it became plus. So the x is actually a negative 2. And the y is actually a positive 6 because it is subtraction there. So that's one of the weird parts about point slope form. Alright, so here's an example I'd like you to try now. A line passes through the point 8, negative 4, and has a slope of 2/3. What is an equation in point slope form of the line? So go ahead and try number 1. Alright, so what I'm going to do is I'm going to use point slope form. Y minus, well, we already mixed that up. Y minus y1 equals m times x minus x1. And the three parts we plug in are point for the x1 and the y1, and the slope for m. So, whoa, whoa, whoa. Going crazy here. So what I'd like to do is to plug that in. So we have our x1 and our y1 and our m. So if we plug those in, we'd have y minus y1 is negative 4 equals, oh, our m is 2/3. We're going to multiply that by x minus whatever x1 is, and in this case x1 is 8. So the only part about this that's not complete is this part over here, because we have a minus and negative, it becomes a plus. So this final equation would be y plus 4 equals 2/3 times x minus 8. Ah, stop it. And there you go. So, before we go to bed tonight, say this 5 times. Then say this 10 times. Point slope form is y minus y1 equals m times x minus x1. Y minus y1 equals m times x minus x1. Y minus y1. Just keep saying that. You'll get it down. Alright, second part I want to do today is graphing with point slope form. So we're going to make this quick. So, I'm going to give you a problem that says, what is the graph of the equation y minus 1, so that would be our y1, equals 2/3 times x minus 2. So remember, before we even start, you can tell that the slope is 2/3, so that's our rise or run. And there's a point, the x1 would be 2, and y1 would be 1. They're both going to be positive because the subtraction symbol is still there. So the equation in point slope form, so again, 2, 1, and the slope is 2/3. So what you can do is you can start by graphing that point, because you know that point is there. So graph the point 2, 1 right here, and then use the slope to find more points. And I think I wrote this wrong, 2/3. So your rise is 2, your run is 3, 2/3. Do that again. Rise 2, run would be 3, and this would make the line. Very similar to graphing the slope-intercept point form, except we're not starting at the y-intercept this time, we're starting at the point that we're given. So why don't you get a graph paper and try to graph this one. What is the graph of the equation y plus 7 equals negative 4/5 times x minus 4? Alright, so before you do that, or now that you've done that, make sure that you know what the slope is and what the point is. So we know the slope is that negative 4/5. That's the m. So this would be the x1, and this would be the y1. But you might notice something about the x1, that's going to be 4. It is still minus, but the y1, there's a plus. So whenever there's a plus, that means that you had a negative value, because it'd be it's supposed to be y minus, so it was y minus negative 7. So then the y value is actually negative 7. So if you take your graph, so now have your coordinate plane, hopefully you can see mine. I'm going to plot the point 4 and negative 7. So 1, 2, 3, 4, and down 7, that's going to be way over here. So it's going to be a tough one to do. 4 and negative 7. So typically my rise would be -4, my run would be 5. So I'd go down 4. So if I were to have 1, 2, 3, 4, down 1, 2, 3, 4, and over 5, since their slope is 5, it'd be going over 1, 2, 3, 4, 5. So it'd be right about there. I can also go backwards. I can go um, up 4, 1, 2, 3, 4, and back 5, 1, 2, 3, 4, 5. So we just keep making those steps. And you can go back again. 5 and up 4. And it would make these steps. And then you can draw a line. As long as you have 3 points, you're good to go. So my line's going to look like this. And that is the line graphed from that equation. So we're going to finish up the rest of this next time. Um, but our goal, remember, is to write and graph linear equations. And we've done that. We wrote and we graphed linear equations in point-slope form. We're going to finish up next time with writing equations or graphing it when you're given 2 points. We'll see you next time.